Friends, good evening. Welcome to Gate Wallah. I am Venkat Rao. We are continuing our lecture series of Theory of Computation. Today is our lecture number 8. So, in previous sessions, we discussed some topics of Theory of Computation. The first chapter of Theory of Computation, that is Finite Automata. Actually, the name of the first topic is Finite Automata on Regular Languages. So, till now, we studied concepts of finite automata, deterministic finite automata, non-deterministic finite automata, epsilon NFA. These concepts already we covered. After that, our next concept is regular languages. Regular languages. So today onwards, our focus is on regular language. So today our topic is detection of regular language. What type of language comes under regular? What type of languages not comes under regular? So students, before going to start the session, please confirm audio and video is clear or not. If you are facing any difficulty in audio video, please inform me in chat box. I hope it is clear. Nobody is responding, so I am continuing. Right. If anybody having any problem, anybody facing any problem in audio or video quality or any disturbance in the audio, please inform me. Right. So our discussion is regarding theory of computation for GATE 2025 point of view. We have selected the subject as theory of computation. Our discussion is going on theory of computation subject. Right. So before going to start regular language topic, let me recap what we studied till now. So finite automata topic, that is what we covered till now. Finite automata. Name of the first topic actually is finite automata on regular languages. On that finite automata part we completed. Right. So in this finite automata, the subtopics like deterministic finite automata we completed, studied all the possibilities, construction of DFA, how to construct the deterministic finite automata, then language to DFA, if language is given, detection of DFA is given, detection of language, regular expressions, minimization of the DFA, epsilon NFA. So NFA, non-deterministic finite automata, and then epsilon NFA. We covered these topics already. Then we move to regular expression. Regular expression. What is regular expression? How to construct regular expressions? Those things we studied. Right. With this, so concepts of regular expressions, finite automata, these things completed. So in today's session, we are going for regular languages. What is general meaning of regular language? A language is said to be regular. The meaning of regular language is a language is said to be regular if there exists DFA for that language or if there exists finite automata. We have studied one topic called as expressive power. So the expressive power of DFA, NFA, epsilon NFA is same. So for any language, DFA exists, NFA also exists, epsilon NFA also exists. All these three things exist here. That's why, so having DFA means having NFA and having epsilon NFA. Right. So for any language, finite automata exists means DFA should exist, NFA should exist, epsilon NFA should exist. There is a equivalence on these three. Expressive power of NFA, epsilon NFA, DFA, same. Right. So with this, we can start our regular languages. Regular language detection. The regular language, first thing we are studying here is, still we are in this part only. So now onwards, every day we will see this. This is called as Chomsky hierarchy. The name of this one is Chomsky hierarchy. Every day we will see what is Chomsky hierarchy, where we are in on which topic we are studying from the Chomsky hierarchy. Where is the position of our topic in Chomsky hierarchy? All these things we will study in every day. So actually these are the 4 places in Chomsky hierarchy. For that, till now we are in the first part, that is regular part. Right. Once we completed regular detection, regular languages concept, then the concept of this first one, finite automata regular language, is over. Then we can move to our next one, that is push down automata context free things. Right. So in that first one is detection, regular language detection. When we can say a language is regular, when a language is not regular. These things we have to detect. So regular languages are nothing but, still now very simple, the language for which DFA exists. The language for which DFA exists, regular. Otherwise, the language for which regular expression exists. And then also all are same only. So this is the general definition, but we don't want that. A language for which FA exists, known as regular language. A language for which FA exists, known as regular language. FA exists or regular expression exists. This is what we studied till now. RE exists, regular expression exists. Then also known as regular language. So a language for which finite automata exists, known as regular language, or regular expression exists, then also regular language. But this much is not sufficient. We'll see. Now today we are in the discussion of regular languages. Just a minute. Hello students, seems some students are joining now. Welcome. Today's topic is very important, definite question in every year gate paper from this topic. Definitely we have one question. Language detection, sometimes from regular part, sometimes from CFL part, sometimes from REL part. So all these are almost combined concepts. So today we are in the detection of regular. Whenever we are studying theory of computation, you have to view theory of computation in 2 parts. One is the automata part, one is the language part. Gate 2025. Yes. I am teaching from Hyderabad. Right. So so whenever we are studying theory of computation, view theory of computation in two things. The subject TOC, we can visualize this way. One thing is automata, other thing is language. Automata is one part, language is one part. Whenever theory of computation subject you say, so visualize theory of computation in two categories. We divide the subject into two types, two categories. In one side you have to study automata, one side we have to study languages. In automata, what we study generally is finite automata, push down automata, Turing machine. Finite automata, push down automata, Turing machine. In language part, what are the languages? Regular, CFL, REL, recursive enumerable languages. One more, that is LBA, we don't study, that is not there for syllabus point of view. Generally we don't get questions. Linear bounded automata. So for this automata, this is the language. For this automata, this is the language. For this automata, this is the language. So whenever we are preparing for GATE, any student who is preparing for GATE, especially subject theory of computation, you have to see the subject in this way. We need to study some automata, we need to study some languages. Assume why the division is important means, there are some questions, 30 to 40% weightage is for languages, remaining 60% weightage is for automata. The questions will come like this. Assume 10 marks they are giving, definitely 3 or 4 marks will get from languages. Language questions are very easy. Whenever language questions are given, very easy, we have so many tricks to detect languages. So automata, solving automata questions is somewhat tricky, somewhat lengthier also, but language, there is no much confusion in languages, very easy. 4 marks given, we can score all the 4 marks as it is. So I will tell you, I will teach you so many tricks here to detect languages, those tricks enough to identify languages. That's why whenever you are preparing for GATE, so visualize the subject this way. So study separately languages, study separately automata, then which automata, generally this is a difficulty level. Finite automata easy one, then PDA somewhat difficult, Turing machine is the somewhat complex one. Generally Turing machine is a complex automata here. Right. So today we are in the language part. I told you language topic is very easy. Definite question in GATE paper. We can score easily. This is what the advantage of language part. That's why whenever we are studying language part, focus properly on those questions, language questions. Some people are saying NFA is difficult. For construction point of view, out of DFA and NFA, which is easy? Actually, what is the major difference between NFA and DFA? For any language, if DFA is difficult, then we will construct NFA. NFA is very easy to construct. Right. We will construct NFA for some languages in the coming classes, okay? Then you can feel the construction of NFA is easy. Yeah, if anybody missed classes, then watch those recordings. Right. So this is what our aim in today's session. So in today's session, we are focusing on regular languages. Whenever you say language topic, in that mainly two things we have to study. Whenever we are studying language, two things. One is detection of that language. Assume regular language, which is regular, which is not a regular. Then closure properties. There are only two topics. If you are familiar with these two, definitely you'll get a good score. For full TOC, that will be in app classes. Mostly from next month onwards, it will start. From April onwards, it will start. Right. So let us go and study this regular languages. First, we'll go for detection. Which type of language regular, which are not regular. Which are regular, which are non-regular. There are some languages here. These are not options, questions, not like that. I am selecting some languages where it is, when it is regular, when it is not regular. Those things we need to identify. See, let us write some rules here. Let me check whether these rules there or not there. Whenever we are detecting, so these are the important points you need to identify. First point. How you are feeling this subject theory of computation? Easy one or difficult one? Generally, how students will feel about this subject theory of computation? So according to my experience, right, seems somewhat easy, but we'll get tricky questions, logical questions. Chomsky normal form, CNF, और 2 or 3 classes के बाद, after 2 or 3 classes. Right. Okay. Let us see here. I can teach this subject 150 hours, 100 hours, 50 hours also. This is a very lengthy subject, so many topics involved. So level of the subject varies. Right. So anyhow, we are in initial. By that time we reach November or December, you can get wonderful understanding about this subject. Complete all my sessions once. You will love this subject. You will enjoy this subject. You can enjoy a lot on this subject. Right. See, the first point what you need to observe is, if you want to detect a language is regular or not, the language is finite or infinite. Whenever you say language, two things are important. The language is finite language or infinite language. So this is the conclusion you have to make first. Right. Whenever we are analyzing language, identify the language comes under finite nature or infinite nature. If the language is finite, that should be regular. So the relation between finite language and regular language are like this. This is a finite language. This is a regular language. So if a language is finite, it should be regular. If a language is finite, it should be regular. Finite is subclass to regular. So that's why first, what in the detection of regular languages, what you need to identify is given language is a regular language or a finite language or not. If it is finite, we can say blindly that is regular, because every finite language is regular. So there is no confusion in finite languages. Finite languages are very, very good languages. If a language is finite, that is definitely regular. So we can construct for every finite language, we can construct DFA, we can construct regular expression. Finite language will not create any problem in theory of computation. Whenever the language comes under infinite, then some of the if the language is infinite, some will fall under regular, some will fall under non-regular. Here the confusion starts. So we need to solve the questions carefully for infinite languages. So if the language is finite, very happy, need not to worry anything, that is regular, everything is possible. Finite automata, regular expression, everything is possible. Whenever language is infinite, sometime regular, sometime non-regular. There we have to solve them carefully. So this is the first point you need to understand. Is it clear about this point? What is the relation between finite language and regular languages? So whenever a language is finite, it is regular. So every finite language is regular, but every regular language need not be finite. So regular languages can be infinite as well. Regular language can be sometimes finite, sometimes infinite. So this is the relation between these two. Finite language is regular, regular language need not be finite, right? Then based on this, let us solve some concepts here, some of the questions. Can you tell me? What is the first one? A power n, B power n, C power n. And this is a finite language or infinite language? First one. Finite language or infinite language? Finite or infinite? So this is the n values in this range. See, the language seems to be A power n, B power n, C power n comparison. That is later. First check the language is finite or not. So number of strings, we can take n value as 1, 1 value as 2. At the max, n value is 1000. Right? So finite number of strings exists. This is a finite language. Whenever a language is finite, definitely it should be regular. language is finite, it is regular. This is a way of solving these questions. So to solve the questions, first thing we have to check is whether the language comes under finite nature or infinite nature. If finite nature, see, conditions are not the thing. If you apply these conditions, how many number of strings are coming? How many number of strings we can frame? If you observe the number of strings here, then the number of strings will be almost 1000 strings present in the language. So if it is the case, finite number of strings, that is regular. Now come to the second language. First language clear. So if it is finite, no need to think about that. That is regular. Coming to the second one. What about second one, finite or infinite? The language second one is finite language or infinite language? Second language is, tell me finite or infinite. I want whether it is finite or infinite. We are in the finiteness analysis now. How many strings possible, finite strings or infinite strings? So here it's not mentioned anything, but whenever n plus m value, it has to be 10 means how we can generate a power 0, b power 10, a1, b9, a2, b8 and so on, a10, b0. So these strings are ending here. Number of strings are finite. Whenever it is finite, then regular. If it is comes under finite, then it should be regular. Similarly, let us check for the third one. First tell me third one is finite or infinite? Finite or infinite? Third one is infinite language. Third one comes under infinite language, because whenever you take n, m plus 5, n comma m can be anything. So here you can take 1, here it can be, m value can be anything. N value 1, m is 2, 3, 4 and so on infinite. N is 2, m is 2, 3, 4 and so on infinite. Like this is the infinite language. Now is it regular? Okay, anyhow we will solve this question after solving fourth one. Now what about fourth one, finite or infinite? Fourth one comes under finite or infinite. N and m if you multiply it is 100, it should be 100. This is clearly a finite language. Observe here, clearly a finite language. How the strings will be generated? If you see here, a value 1, b value 100, a value 2, b value 50. So if I multiply n and m value, we have to get 100. 4, b value 25, a value 100, b value 1 and so on. These strings, finite number of strings. So fourth one is finite or infinite? Definitely finite. So finite, then it is regular or non-regular? Whenever it is finite, it comes under regular or non-regular? Finite means definitely comes under regular. So first one regular, second one regular, fourth one regular. Now we need to conclude about third one. See, if till now what is the conclusion we made? If a language is finite, if a language is finite, definitely that falls under regular. I am making one small chart kind of thing. Definitely regular. Whenever language comes under infinite, then confusion starts. Sometimes it can be non-regular in infinite languages. Some falls under non-regular, some falls under regular. In which case non-regular, in which case regular, in infinite cases. See, whenever a language is infinite, if comparison exists, this topic we studied already in DFA, comparison exists if dependency going on between the strings. So this is like a power n, b power n. The comparison or dependency concept I explained you already. A power n, b power n. If I generate a as 2, how many b's I can generate here? Can I generate any number? Any number of b's not allowed. Number of b's should be exactly 2. So the generation of b's completely depends on a. B's generation depends on a. This dependency, comparison, then non-regular. That means there should be a freedom on the languages while generating the strings. Whenever I am generating a's, number of a's, there should be a freedom. Number of b's, there should be a freedom. Then those type of languages for which we can construct finite automata. Whenever there is a dependency, if there is a comparison, then definitely memory is required in the finite automata. But actually finite automata don't have that memory to remember that infinite memory. So finite automata fails. This is the actual reason. Finite automata fails, non-regular. So the way we can remember is, if comparison exists in the language, then non-regular. This is one example, and if we see some other example here, what about this language L2? Comes under regular or non-regular? Language L2 comes under regular or non-regular? If you see this language L2, a power n, b power 2m, so here assume I can generate, if I take number of a's as 2, how many b's I can generate? There is no restriction on number of b's. We need not to take the decision of b's by depending on a's. You can generate any number of b's here. So number of b's I can generate here as 10,000 b's I can generate. What is the problem? Otherwise 1 lakh b's I can generate. What is the problem? So number of b's generation not depending on a's generation. So a's and b's are independently there. There is no dependency on symbols of the language. Dependency not there, comparison not there, then that is regular. So here in this example, this is a non-regular, this is a regular. So what you need to observe here is, whenever a language is infinite, comparison exists or not, you need to check. That is a key point. Comparison exists, non-regular. So this is the way we can conclude. So comparisons exist or not in infinite language, we have to see. Comparisons exist, non-regular. Comparisons not there, make it as regular. Right. Come to the third example. So we can rewrite this language in the third example like this. A power n value if I replace m plus 5, b value as m. This language will be converted this way. A power m plus 5, b power m. Now what happens? If I take m value as 1, a value is m plus 5, and m value as 2, that is 7. So always the number of phases depending on the generation of number of phases depending on number of base generation here. Right? So there is a comparison. This is an infinite language. Comparison is there between A's and B's. Comparison is there. This comes under non-regular. This is non-regular language. Clear, right? So these are the 4 languages on which we performed. So 1, 2 and 4 are regular languages. Third one is non-regular language. So this is the way. First check finite or infinite. Finite, directly regular. Infinite, comparison exists or not. Comparison exists in infinite case. Non-regular, no comparison, regular. This is the way we will conclude about these questions. Now let us perform detection on some of the other languages. Here I have given 3 languages. What about the first one? If you want, you can rewrite this language like this. A power in the place of n, 2m plus 1, b power m. Now this is a finite language or infinite language? Finite language or infinite language? M values starting from 1, you can take anything. You can take starting from 0 also. M value 0, M value 1, M value 2, M value can be anything. So this is clearly infinite. Infinite. Any comparison exist? Any comparison exist? See here, always if I take n 1, then it is 3. If I take 2, this is 7. Number of A's generation is always depends on B's. There is a comparison here, A's and B's generation, in which comparison exists. Comparison exists. If comparison exists, there is a comparison. If comparison exists, the language comes under non-regular. Am I right? Is it clear? Okay. And students generally will get one more doubt. There is a language here. There is a language here. There is a language here. Yes, comparison happen. Yes, Dinesh. Comparison happen, then it comes under non-regular. I'm showing you, I'm just written 3 languages here. What I am showing here, 3 languages. The difference in these 3 languages is L1 value starting from 1 to 5. Here n greater than or equal to 1. Here not mention anything. So what about first language? Is it finite language or infinite language? What is the first one? Is it a finite language or infinite language? See, n value 1 to 5 in between only. The maximum value of n will be 5, the minimum is 1. So this is clearly finite language. What about second one, L2, finite or infinite? N value I can start from 1, greater than or equal to 1, anything. N value can be 2, n value can be 3, n value can be 4, n value can be anything. So this is clearly infinite language. Clearly a infinite language. So first one is clearly finite language, second one is clearly infinite language. What about third one? Say n value mentioned here, finite, so I am assuming finite. N value mentioned infinite, I am assuming infinite. Here in L3 not mentioned anything. There are so many questions of this type here. Then what we will select? If not mentioned, by default, what we have to assume? Finite or infinite? That is the question. So what is L3 now? Is it a finite language or infinite language? What is L3, finite or infinite? See, if not mention anything about the language, finite or infinite, by default we have to assume it as infinite language. Assume as infinite language. So if mentioned finite, infinite, okay. If not mentioned, default you have to assume as infinite. Why I am explaining this is, this situation is there here. Come to the language second one, n greater than m. N value, m value not mentioned anything. So it is second one is comes under finite or infinite. So if not mention anything, the default case, infinite. So the number of strings, we keep on, we can generate infinite times. If it is infinite, any comparison, A should be greater than B's. There is a comparison, A should be greater than B's. If A's are greater than B's, comparison exists. Then comes under non-regular. Clear? Right. What about the third language? Finite or infinite? Sorry, regular or non-regular? Third one. N greater than M, and so if still letters not visible, then for you I am writing separately. A power n, b power m, n greater than m, and n less than m. N greater than m as well as n less than m. Regular or non-regular? So any other answers from anyone? Answering this type of language is very logical, very confusing also. This language is clearly regular. This is regular. So it seems like comparisons and all this, but to compare, where we are comparing generally, the comparison between strings. But see the language, tell me from this language, tell me one string in which A is followed by B's. Tell me one string in which number of A's greater than B's, as well as number of A's less than B's. Tell me one string in which A is greater as well as A is lesser. Is there any string like that? A is greater होना है and A is lesser भी होना है. A is greater as well as A is lesser. Is there any string of that kind? Generally there is no string. So the language is nothing but phi, empty language. The regular expression phi. There is a DFA for this. The DFA for this will be like this. There is no final state. Regular expression exists, DFA exists, clearly regular. Proved. So carefully we have to solve these questions. Whenever we are solving these regular questions, we need to take a lot of care. Any confusion in this? So our language is nothing but this one. Comparison exist or not exist means where in strings, but there is no string at all. There is no string at all. Then where is the confusion concept? Where is the comparison concept? That's why it is clearly empty language. For empty language, regular expression possible, DFA possible. The DFA in which no final states, all non-final states. The DFA accepts what? Empty language only. That's why DFA exists means regular, definitely regular. Okay. Four languages given. Tell me about the first one. It looks like previous one, but there it is AND. Now it is OR. Whenever AND given, OR given, then total language strings changes. Now tell me this language comes under finite or infinite. See, whenever we are generating strings in which either A's can be greater or A's can be lesser. Previously AND is there, but now it is OR. So I can take number of A's greater or number of B's greater, anything. So this language is finally A power n, B power m, n not equal to m. This is the structure of this language, right? So whenever A's, it can be A's can be more in the string or B's can be more. They never be equal. So the language is nothing but A power n, B power n, n not equal to m. So this is finite or infinite? Clearly infinite. Comparison exists. If comparison exists, then what is the result of that? Non-regular. Right? Any doubt in this? Then what about second one? A power n, B power n, C power n plus 1. This is clearly infinite language. Infinite language. Because n comma m value can be anything. Now any comparison exists. Whenever it is infinite, our main concept is whether comparison exists or not, that we have to see. See here, number of A's and B's should be equal with number of C's. So this comparison we need to observe. Either number of A's and B's, is it equal with number of C's or not? Comparison exists. So comparison exists. Then comes under non-regular. Right. So in the similar way, you can take third one as homework. You can think about this if you are getting any doubt. A power n, B power n plus m, n comma m. I am checking for fourth one. Fourth one, infinite language. Infinite language. Third one is infinite. Okay, third one, some people are saying infinite. So third one also I am concluding why infinite. Comparison exists. So the answer is non-regular. Comparison non-regular. What about fourth one? That is infinite. Any comparison, A value is n, B value is 2 power m, C value is 3 power k. Any comparison? See, A value can be anything. You can take A value as 10. Is B value depending on this? No. You can take anything. B value as 200, 300, whatever you want. C value is depending on A and B? No, it can be anything. C value can be 1 lakh or 10,000, 30,000. Anything. Multiples of 3. It can be multiples of 2 like this. A's and B's and C's are independently there. There is no dependency, no comparison. So clearly non-regular. Clear? Any confusion in any of these 4 languages? Any confusion in any of this? Right. We'll solve some of the gate questions asked on this. If it is a before that, let us see for some more languages. This one. Let me check for one of this. Yes, no comparison means regular. Now what about this language? Tell me. This is clearly infinite language. Clearly infinite language. So whenever infinite language, generally what we are performing till now, comparison concept. But whenever there is only one symbol, where is the concept of comparison? That's why for one symbol language, see all these languages, almost one symbol. Whenever a language is formed over one symbol, here symbol is only A, strings formed over A. For one symbol language, comparison concept will not work. The concept of comparison will not work. We need to go for whenever a language formed over one symbol, common difference. This topic we studied in DFA. If common difference is not there, can we construct DFA? Common difference is not there, can we construct DFA? No, right. So for one symbol languages, common difference is the key point. Common difference exists between strings. DFA possible, regular. No common difference, non-regular. This is the key point here. So if language is formed over one symbol, common difference exists, then language is regular. No common difference, not regular. If common difference exists, then it is regular. No common difference, not regular. So what about this language? A power 1 power 1, A power 2 power 2, A power 3 power 3. Is there any common difference in the generated strings? So how the strings are generated? Any common difference thing? No common difference. So here no common difference. If no common difference comes under non-regular. Non-regular. Okay, let me give some numbers for this. L1, L2, L3, L4, L5, L6. Now let us solve for this L4 language. Let us solve for this L4 language. L4 is like this. P is a prime number. Language is formed over one symbol. Whenever one symbol, then common difference is the concept. So regular or non-regular? Class continues for 5 more minutes. Right. So here what are the any common difference in prime numbers? Any common difference in prime numbers? No common difference. So here no common difference. And so on. So sometimes 1 is the difference, sometimes 2 is the difference, sometimes 4 is the difference. There is no common difference. So clearly non-regular. Language non-regular. Now let us solve the third one, L3. A power p whole star, p is a prime number. Let me write separately. P is a prime number. It is whole star. What about this language? Regular. Any common difference? So prime a power p whole star on that. If you take p value is a prime number, so this is, if you take 2, it's star, it is 3, it's star, if it is 5, it's star, if it is 7, it's star, and so on. What is the common difference in this language? How the strings will be generated? See the way of generating strings. Epsilon generated. Identify type of strings. Can we generate single A? That is not possible. 2A's generated. Yes. Take this one time. 3A's generated from this. Any of this one. 3 generated. Yes. 4 generated 2 times of this. 5 generated from this. 6 generated. Yes. 7 generated. Yes. This is generating all the strings except single A. So the common difference here after epsilon single A, all number of A's will be generated. Common difference is 1. If we are confusing about common difference, to prove this, we can construct a DFA as well. Epsilon accept, 1A reject, 2A's accept. After that, everything accept. We have a 3-state DFA also for this. So this language is clearly regular. Is it clear? So common difference is there. Common difference is not there up to particular strings. After that, common difference definitely exists. So this is the way. Whenever you are solving about one symbol languages, languages are formed over one symbol, then common difference is a major concept. So if common difference is there after particular strings also, then we can construct a DFA, the language becomes regular. If common difference is not there, that becomes non-regular. So observe this, these two are very, very important. L3 as well as L4. L3, L4. Looks almost similar. A power p is a prime number, a power p is a prime number. Whenever a power p whole star clean closure is given, then it is becoming regular. If just it is a prime number, then it is non-regular. So there are so many languages of similar kind, and sometimes they becomes regular, sometimes they becomes non-regular. So all these type of there are so many confusing and variety of beautiful languages are there. Those things we'll study in the next class, tomorrow session. So that's all about this session, students. Thank you. Bye bye. Some beautiful language, some important languages and gate questions we'll see in the tomorrow session. Okay. Bye bye. See you in next class.